within the Earth, there is gradual movement going on. To move the Earth's crust, you have to have a heck of a lot of power, because even though the crust in this area is moving about that much every year, about 4 centimeters a year, it's a lot of rock going down several tens of kilometers, moving and colliding with another part of the Earth. We're on a plate boundary, so one plate is moving towards the other, and the one that we're on is riding over, on top of, the one that's coming towards us and going underneath. So right beneath us, the plate boundary is about 20 kilometers down. And if you go in that direction, it's gradually coming up towards the surface, and out in the ocean, beyond those hills, is the actual surface meeting point of the plate that is going down and the plate that's going over. They meet at a plate on the surface. And it's out in the ocean. So what's going on is these two plates are pushing towards each other, and unfortunately for you and me, they're not gradually sliding. They're caught against each other. There's too much friction. And the one that's going down is stuck to the one on top and is slowly bending it downwards. So Wellington and this area are actually every year going down a couple of millimeters. You can measure this with GPS stations around the place. They are sinking slowly down. I'm trying to do a demonstration. Over there, we've got a plate coming down this way. Over here, we're on top of this one, and it's caught together, so it's being pulled down. Okay? They are stuck. Geologists say they are coupled together. And sometimes they, over a very short period of weeks, they release a little bit, they move a little bit, and it's called a slow earthquake. Nobody feels it, but this land on top might move half a meter sideways or up a little bit or something. So you have these slow earthquakes, and they're quite new to science, because we never knew about them until we realised we could measure them with GPS stations. But anyway, sometimes you have the slow motion earthquakes, and that's great, nobody's hurt. But sometimes this thing goes down and releases suddenly. And so the stuff that's been bending downwards goes boom, up. Now that bit that jumps up is also on the land, but also out to sea. And when you jump up the sea floor in a very rapid motion, you push all of the water above that upwards. So it's now bulging up above the sea level, and it's got to get the hell out of there, because water always finds its own level, so it moves in all directions as a tsunami.
Yay.
So when that earthquake happened that you saw this morning, the 18 odd meters of sideways movement, scientists aren't quite sure, but they think that might have been deep down. That fault might have gone all the way down to the plate boundary, and it might have been a plate boundary fault. There was in fact a tsunami that washed all the way around this coastline. It was about 10 meters high, so that means if you were standing here you would definitely be washed around. And some buildings were damaged. I'm not sure, some people were killed, but maybe, but not very many. It was very small population. So the fault that we were looking at comes out just down here a little way, and it follows under the ocean, but just in front of these hills.
I can still.
Yep.
I can still South Island.
Yes, you can. You can.
Oh
So,
yeah, I can see it too.
but we'll just try to stay with the conversation. So that land is when the earthquakes happen on that fault, the land moves sideways and up. So we measured the sideways movement, but you also saw that there was an up step in the landscape. So it's doing that. It's called an oblique slip fault. So there's a whole load of activity happening in this area. And a great way to understand over there, if you look behind that blue car now, in the distance, can you see that the land has these flat ledges on it, like the hills are flat around the place?
Yeah.
And there's one on the skyline at the very end, And if you look behind it in places, you can see there are other ones going up like a staircase.
Oh yeah.
Okay? There's the land. It somehow is slowly moving up, but right now the ocean is washing into it and eroding into the land and making a cliff. And that cliff is being washed back and back and back, and so all of that material goes out into the sea and fills up the hollows and makes a very shallow area. So all of the sea out here is very shallow.
Yeah, you can tell that because of the light blue colour.
Cool. Okay, so it's very shallow. Now, over time, this land is moving up, right? So sometimes that shallow sea actually gets pushed up out of the sea and rises up to form a future hill, like those. But the funny thing is that you might think, why do they form such a clear line if they are slowly coming up 1 meter at a time over thousands of years? This is your university level 101 answer. See if you can work it out. Well, no, I'll just tell you, but see if you can kind of work out what I'm saying. Shallow sea, working its way into the hill, leveling everything off, okay? The beach included, the beach kind of goes down and goes into the sea, so there's a bit of beach and there's a bit of under the water, but not very deep. But over time, we have these things called ice age cycles, and the sea doesn't stay at the same level. So in a warm period, it's high, but when it gets really cold, all of the water evaporating from the ocean that normally rains down again, actually doesn't rain down, it snows down in Antarctica or in Canada or Greenland. And so the sea level doesn't get replenished, it actually goes down. And during an ice age, let's say every 100,000 years, the sea level goes down. And then it warms up again, and so the snow and ice melts and the sea fills up. And it comes back to its original level, but in the meantime, the land has been pushing up. So the flat area that used to be on the coast has now been pushed up away while the sea retreated far away. The flat bit came up, and now the sea comes back in, and it's cutting its way in again to make a new flat level, but it can't get back to its first flat level because it's been pushed up. Does that make sense?
Yeah.
So when you look across there, you're seeing the land that was at sea level about 100,000 years ago. So now we can be clever and we can say, if we measured the altitude of that flat surface and we made an estimate that it's about 100,000 years ago that it was at sea level, we could start to work out how fast is the land rising up in this area due to plate tectonic collision. Make sense?
Yep.
If we go back if we go to look at another layer higher up, we could say maybe that's about another 100,000 years ago. And yeah, because it's been eroded and cut back more, but you can see them. So you might go back 300,000 years and see the land that used to be at sea level, how much it's been pushed up by many, many earthquakes. So that's explaining what's called marine terraces that you see all around this coast. Even this one above us is a marine terrace. It's very flat. It looks a bit, you can't see it, but if you saw it from, if you're on top of it, you'd see it was very flat. Awesome.
Soames Island has those terraces?
Yes.
Yeah, there's 3 of them.
Soames Island has 3.
Yeah.
Exactly. You see them all over the place once you start noticing them. And they've been pushed up over time as the sea level's gone out, come back, gone out, come back, and it's made these steps. Brilliant. Now that's just part 1. Part 2, we look back to these hills. Can you notice there are landslides, sometimes a bit vegetated, but there are these landslide scars
Oh yeah.
around the place? You saw there's a really big one back there. Those all happened in the 1855 earthquake. And so if you go back to Lake Ferry, that way, and look at the range, you can see that there's lots and lots of landslides at that end. And as you go up towards Masterton, there's less and less. You can't see it so well from here. But the landslides, you could say, demonstrate that the greatest shaking of that earthquake was that end, and it gets less and less towards Masterton. So that's that's another interesting thing. You can just observe in the landscape. In 1855, those landslides were occurred. And since then, they've never revegetated because the wild wind and the steep slopes, it's all crumbly. The vegetation has a really hard time getting established again. So that's why you still see them. And yeah, this is an epically rough weather landscape. You know, there's a lot of strong winds, cold winds, stormy ocean, etc. And then the last thing to say, maybe. Oh, actually, no. A couple more things. You can see this little valley here is very full of debris. It's not been cut down into a nice little valley with a little stream at the bottom. It's spread right across, it's choked up with rocks. And that's a result of the rapid erosion that's happening of these mountains, which are being pushed up very fast by global standards. Probably a centimetre a year on average, but not slowly. If you like, nothing happens and then suddenly goes up a couple of metres. Nothing happens, suddenly goes up another metre in an earthquake. So the fact that there's lots and lots of rock debris is telling us this is an active uplifting landscape, and it's also actively eroding down because of the wild weather. Last thing, let's imagine it this way. If we were to go out to sea right now and dive down with a scuba diver, and we're going to dive down 10 metres into the ocean, what sort of material do you think the sea floor would be made of? Stones. Yeah?
It'd have a lot of wood in it too.
Maybe fragments of wood, absolutely. Maybe there'll be sandy bits, slightly rocky bits, but the sea is washing them around, so they might get a bit more rounded than you see here. See, the very fact that these rocks here, they've got sharp angles, tells you that that's pretty close to where it fell off the hillside. It's not been rolled around much, but you put it out by the shore there, and it'll be very interesting to go and see actually. Are the pebbles a little bit more rounded because they've been rolled around?
Can we go?
We could have a look. So, but if you go down there, you'd expect to see mud, gravel, sand. Now, don't forget, this whole area has been pushed out of the sea. So would it make sense to think in these cliffs we would see the material that on present day is out there, but in the past, this is older stuff that's been pushed up.
Yeah, like right here.
Does that make sense? Excellent.
Muddy.
Good. And one thing you might notice is that there's gravel layers and then mud layers.
Yeah.
Gravel, mud. Gravel, mud. Maybe those represent earthquakes, more gravel, fresher material, slowing down, more mud. It could represent previous sea level changes, deep sea mud, shallow water gravel. We have to look. All right, well done for listening, that's great. So there's a lot you can see in the landscape. So really the message to take home, open your eyes, have a look, ask questions to yourself, why is that there?